Okay. Okay. We are online. One moment, please. Okay. Morning, everyone. Welcome to this session number 384. And today I have this. Oh my gosh. It's a daily challenge. Yeah, sure. This problem is a daily challenge. Is the final champion 2. I don't know what is the one. What, whatever. And in this case is the problem I shared in the chat, and essentially is this: find champion 2. There are n teams numbered from 0 to n-1 in a tournament. Each team is also known in DAG. I forget the meaning of that. Direct acyclic graph. Okay. You are given an integer n and 0 index to the array h of length m, representing the DAG, where h in index I it's equal u I b I, indicates that there is a direct h from the team u to the team b in the graph. A direct h from A to B is the graph means that the team A is stronger. Okay, the direct h between A to B in the graph means that the team A is stronger than the team B, and the team B is weaker. What is the meaning of weaker? Let me check. Okay, that team A. Yeah, okay. Team A will be the champions of the tournament if there is not a team B that is okay. If there is not the team B that is stronger than the team A. Okay. Return the team that will be the champions of the tournament if there is a unique champion. Otherwise, return less one. Okay. Okay, I forget to check the Twitch. Okay, nice. And we have these nodes. Cycle is a series of nodes A1, A2, blah blah blah, until n such that the node A1 or node first is the same node at the same yeah, basically a cycle. The nodes are distinct. A DAG is a direct graph that does not have any cycle. Okay, yeah, essentially that is an, I think that is a only direct graph with any cycle. Like this. Now let me check the so sorry. The constraints. The first, that is the n. What is n? I think that is the size, right? Let me check. N is the number of teams. Is 1, and the maximum is 100. The m, that m represents what is the meaning of M? Yeah, sorry. M is equal to h at length. This, and the length of the this is could be 0, and the maximum is n multiplied by n less 1 divided between 2. The h in the index size, the length of this array is 2. Okay, and the array in the index 0 and the index 1, this and these are different always. The input is generated such that if the team A is stronger than the team B is not strong. Okay, yeah. And the input is generated such that if the team A is stronger than the team B and the team B is stronger than the team C, then team A is stronger than the team C. Okay, in this case, for example, we can have 4 teams. Sorry. Return the team that will be champions of the tournament if there is a unique champions. Okay, if we have similar score between 2 more elements, is less 1. The team 2 is weaker than the team 0 and the team 1. The team 3 is weaker than the team 1, but the team 1 and the team 0 are not weaker than any another team, so that the answer is less 1. Okay, let me check or copy this. Okay, now for this, I think that I need to change my little tablet. I think that I will feel much comfort with a new one, a little more big. But well, okay. Now here, now here said that we have this number of teams. Yeah. In this case, we have 3 teams: the team A, B, and C. Okay, and he said that the origin and the destination. The direct h between A to B graph means that in this case, for example, the origin. No, let me change this for the team 0, team 1, and team 2. In this case, the first said that the origin is between 0 and go to 1. In this case, means that this is greater than this. 0 is greater than the team 1, or 0 is stronger, more stronger than 1. Okay. Now, even I will remove this. It's done. Now the next that is 1 is stronger, that is more stronger, or is greater that 2. In this case is like this. You know, in this case the winner is 0. Okay. Okay, now here, for example, we have the team. We have 4 teams: 0, 1, 2, 3, 0, 1, 2, and 3. Okay, and the first that is 0 is greater than 2, 1 is greater than 3, and 1 is greater than 2. In this case, if I sort this, here for example I can put and the team 2 is weaker than the team 0 and team 1. It's weaker, or it's minor than this. The team 3 is weaker than the team 1. But the team 1 and the team 0 are not weaker than any another teams, so that the answer is 0. Yeah, in this case we have 2 records, and the final we should be have only 1. Yeah, let me check if we have thanks. Okay. Okay, I need to improve my time with these algorithms, because yesterday I had an interview and oh my gosh, in a half hour I can complete my exercise, and I think that is because I need to improve my time in these algorithms. Now here, okay, we have this. We had 19s. Okay, in this case, this number, I think that represent the 0 until n less 1, right? In this case is 8. The maximum number is 8 here. Do you see? 8, and the minimum is 1. Now, in this case, we have that the 8. The 8. Okay, let me try to do the graph. Go to the 6. Now the 6 go to the 3. 6, the 6 go to the 3. The 1 go to the 5. Let me put here 1 go to the 5. The 8 go to the 1. The 8 go to the, no, the 8 is here. Okay, in this case, this go to this direction. The 8 go to the 5. The 1 go to the 4. The 8 go to the 4. Oof. You know what? I remove this. And 4. 1 to the 4. And 8 to the 4. 0 go to the 2. 0 go to the 6, that is this. Okay, means that I can move this. And that's it. Oof. Okay, now I need to figure out what is the winner. Oh, I think that is in essential. Well, I think that the answer is that how many nodes don't have any reference, yeah, for itself. For example, the 8 don't receive the 8 don't receive any arrow in this direction. Means that we have the 8, yeah. Well, it is receive, is discard, 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 and the other is the 8. I think that this is less 1. Let me check. Okay. Where is the test? It's 9. Return less 1. Less 1. Yeah. Is this. Yeah, I think that this is the idea. It's very similar to another problem that I solved a few months ago. I don't remember very well, but I remember that is detecting this. Now, the way to detect if these have any reference itself, I think that is only mapping, right? Is for example, if I map this, okay, now the first time is 8, go to the 6, the 6 go to the 3, the 1 go to the 5, the 8 go to the 5, the 8 go to the 1 and 5, sorry. Go to the 5, the 1 go to the 4, the 8 go to the 4, the 0 go to the 2, and go to the 6. And now the next that is I forget to start the timer. Okay, now the idea is, okay, you can start here and mark okay, if I start, for example, with the 0, we have that the numbers is between 0 and n less 1. Yeah. If I start a for or a loop that start with the index 0, basically is okay. 0 go to the 2, and itself this number is not nor isn't marked or marked as a visit. Is only the elements that appear inside. Basically, this is not counted as a visit. Oh, why appear 8 2 times? 8 1. Okay, this is wrong. This should be disappear. In here should be appear the 6. Sorry, 6. This is signal. Okay. Now, for example, the 0 have the 2 and the 6. Yeah, and it's basically DFS. Yeah. In this case, go to the 2. The 2 is marked as a visit. Yeah, means that this is not part of the elements. Now we have the 2. Now the 2 have elements here. No, it's complete. Now the 6 is part of this element. Yeah, this is marked as a visit. And now the 6 return the number 3. Okay, now go to the number 3. Yeah, in this case it's marked as a visit. The 3 have elements. No. Okay, I can complete this. It's complete this, and it's complete all this flow. Okay, and the 0 is done, but it's not marked as a visit. Now the next that is the 1. We start with the 1, and we have two records, the 5 and 4. We start with the 5. The 5 is at here, and the 5 doesn't exist, is complete. Now the next that is the 4, and the 4 is marked as a visit. Now the 4 contain elements, no, okay, it's done. Now the 2 is contained here, no. Now the 3 is contained here, no. And even I can check here if it's not contained or has been checked before. Sorry, if the number is not contained here but previously or before, I need to check if exists here. If exists here, don't make sense continue with the performing this operation because has been checked before. Okay, in this case we have the 2 is here, is ignored. The 3 is here, is ignored. The 4 is here, is ignored. The 5 is here, is ignored. The 6 is here, is ignored. The 7 doesn't appear. But even the 7 is not appearing here. Okay, I detect one thing here. 7 and the 8 appear here, no, appear here, yeah. In this case the 1, go to the 1, in this case the 1 is marked. Now the 1 return 5 and 4. 5 has been checked before, 4 has been checked before, is complete. Now the next that is the 5. The 5 has been checked before, yeah, is ignored. The next is the 4, has been checked before, is ignored. The 6 has been checked before, yeah, is ignored and is complete. And the 8, this number itself is not marked as a visit, yeah. And that's it. Okay, now one point here is that we need to know how many numbers we have here, because in this case appear in this case we have that all the number except the 7, yeah. And I think that is much better where I fill this map adding these elements in a hash set. For example, in this case, in the hash set we have the 8, well, we have 1, 2, 3, 4, 5, 6, the 7 don't appear, and the 8. We have 1, 2, 3, 4, 5, 6, 8, yeah. And for example, the difference, this is here, is ignored. This is here, is no. This is the complete. Okay, this appear here. Okay, this is appear. This appear here, yeah. This appear, yeah. This appear, yeah. This appear, yeah. And we have no, let me check. Sorry, this is the all the numbers, and this is the numbers that have are receive an arrow, you know, receive an arrow or have one H direct with direction itself, yeah, this. Okay, in this case the 2 have can discard. Okay, yeah, I discard. The 6 is discard. The 3 is discard. The 5 is discard. And the 4 is discard. And the 1 is discard. But here appear 2. Here only have the 8, but should we have less? Should be less 1. I am doing something wrong. Okay, I need to do again this. I think that I have the right idea, but maybe I did something wrong. Okay, now here we have that. Okay, the first is I have a hash set for know how many numbers I have, and the hash map. Yeah, in this case, this is the hash map, and this is the hash set. Sorry. Okay. Now the first that is 8 and 6. Okay. 8 and 6. And here is 8, have the reference to 6. It's done. Now the next that is 6, 3. 6 is here, 3, 6, 3. Done. Now it's 1 to 5. 1 and 5, 1 to 5. Now the next that is 8 and 1. 8 is here, 1 is here, 8 is here, only one the 1. Now the next is 8, 5. The 8 exists here, the 5 exists here, it's only add here. 1 and 4. Here the 4. 8 and 4, 8 and 4 exists, and I'm in, sorry, I was speaking in Spanish. 8, 4, here is this. Now is 0, 2. 0, go 2, 0 appear here, no, the 2 appear here, no, okay. 0 and 6, 0 appear here, yeah, 6 appear here, yeah, 0, go to 6, and it's done. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. Zero, 1, 2, 3, 4, 5, 6, 8. But it's 9. Okay. And we have this mapping. Got it. Now we start with the first number. In this case, for example, the 2. We start with 2. Is remove it of here. Yeah, and the 2. This itself is not used for mark the nodes. It's only for get the reference. Yeah. In this case, the number 2 doesn't exist in this, basically is ignore. Yeah, and in this point here is the element that will be discarded as a greater or stronger nodes. Yeah, in this case anyone, because doesn't exist this. Now the next that is the 8. The 8 contains 6, 1, 5, and 4. We take the first, and obviously is necessary to, yeah, this hash set help us with two propose. The first is discard that all the nodes that appear here can be part as a result, and the other is for validate that the hash set using is using for mark the node as a visit, yeah, for done performing this operation over its nodes. In this case, the first is the 6. The 6 appear here, no. Okay, we take this, we move in this direction, and now this is marked as a visit. And now the 6 have the node 3. The 3 has been checked before, no. Okay, now it's marked and go to this. Now the 3 Is contained here? No. Okay, it's complete. Yeah, and it's complete and it's complete. Now the next that is the one. The one has been checked before. No. Okay, it's marked, and now the one have the values of 5 and 4. Okay, the 5 has been checked before. No. Okay, 5, and this return anyone. Okay, it's complete. Now the next that is the 4. The 4 has been checked before. No. Okay, it's at here. And the 4 don't contain anyone. It's complete, it's complete, it's complete, it's complete, and come back to this. Now the next that is the 5. The 5 has been checked before. Yeah, it's ignored. The 4 has been checked before. Yeah, it's ignored. Okay, and now we complete the 8. It's done. Now the next that is the 6. Is the 6. Now the 6 has been checked before. It's important to validate with this. No. Okay, now the 6 return the 3. The 3 has been checked before. Yeah, okay, this is complete, but it's not marked as a visit. Yeah, because it's only marked where appear here and not in this. Now the next that is the 3. The 3 has been checked before. Yeah, it's ignored. The next that is the 1. The 1 has been checked before. Yeah. The next that is the 5. 5 has been checked before. Yeah. The next that is the 4. The 4 has been checked before. Yeah. And the next is the 0. The 0 has been checked before. No. Okay, now the 0 contains the 2 and the 6. Yeah, in this case the 2 has been checked before. No. It's marked, and now the 2 contains anyone. Is complete. Now the 6, yeah, has been checked before. Yeah, okay, and is complete. Now we have these numbers 1, 2, 3, 4, 5, 6, and in this case we have 1, 2, 3, 4, 5, 6, 7, 8. We have the difference between the size this and the size is this is equal to. With this we can note that we have two winners. Means that is less 1. Yeah, what do you think? Makes sense? Because I don't need validate what is greater than another, because don't have any reference itself. Well, for me at least makes sense. I will try to do in code. Okay, sorry. Now here we need a hash set in hash map, only 2. Hash set scene hash map you know what, I need 2 hash set. The first is for know how many elements I have in the list, and this is the elements that has been discarded, yeah, as a part of the result. This case is this nodes scene hash map integer list integer map. You know what? I move as a global variables and only initialize here. It's equal new hash set now. Here is this and this. Oh, is hash map. And what is the next? The next is transversal all the age for what? Okay, where integer array age. Now it's nodes.add array in the index 0 and in the index 1. This is only for know how many distinct nodes I have. And the other is that map.put if map.contains king but negative of array 1 is wrong there again. Okay, here is integer node a, it's equal this, a node b. I think that is much clearer in this way. Node a, node b. In this case, the map contains the node a, but in negative means that I need to create the register. New array list. I know that it's possible to do with the one operation of the map, absence or something like that, but I don't remember very well at this moment. In this case is get the node add and add the node b. Yeah, this is because in this moment I am sure that exists this record because was created previously. Okay, now this is done. Now we have I have filled completely the nodes and the map. Okay, now the next that is transversal the nodes. In this case it's integer node. Let me check hash set for each. I think that is only in this way, but only I want to be sure. Yeah, nodes and here I need validate if scene contains node but in negative. Okay, performing you can perform the operation, and here it's a DFS that received the initial node. And here a private void DFS integer node and here okay, for example the first is a 2. I need get the values of 2. Okay, for integer nodes and map dot get or default. In this case, is default because could be, for example, for a few records doesn't exist here. Yeah. In this case, node and new array list for return an empty list and don't get an exception. And in this case, is ask if contains n but negative, you can perform this operation. But before, I need to mark this node as a visit before to continue. And now yeah, in here, if scene.size less nodes.size mat.abs, absolute value between this is okay. In this case, is the only case is when it's 1, you can return okay, no, but here I need return the okay. Let me change this for a simple if here. When the difference is different than 1, means that maybe have 2 or more winners, or the size between both hash set is the same, means that all the nodes have at least 1 reference. But I think that is not possible, but well, in this case, return less 1. In other case, here I need to apply a filter, and I think that hash set filter other hash set, I think that is possible. Filter is, no, find intersection, okay, this. We have 1, 3, 5, and 7. In 3, 6, 7, and 8 is 3 and 7. Okay, I think that it's only with retails intersection. What is intersection? Let me check. Retains all. How works? Yeah, but I want to know how works internally. Here. Retain all elements that contain a specific signature was removed from the list of its elements and not contain a specific collection. Class in the class definition is optional upon the reception collection. I think that remove from the list, but I want to know the time complexity. What is the time complexity? Well, I think that is linear. Because need transversal. Well, I think that I can do this, or a simple way, only transversal my nodes, integer sin and no s, yeah, and here remove nodes dot remove s, and only return should be only have one element. And here it's nodes dot remove. The remove return the get items from hash set. Remove. I remember that I can use the index. Remove from the set, yeah, but with integers. I think that is iterator has next. Instead of this is iterator has next. No, but this is next, only next. And it's a function. I think that is this. Integer. Okay, let me check another test. Maybe today is the day where I submit without any error, and the first time. Okay, this. What else? This 21, 51. And one more. This 9. Okay. I think that even I can improve this, because when it's marked as a visit, I can remove from the nodes. Let me check. Maybe it's possible. Nodes that remove n. No, I can do it for the concurrence. Yeah. Well, whatever. Ah, damn. Okay, yeah, is where very near. If h dot length it's equal 0, return less 1. What is wrong? It's 0. Okay, let me do another test. What happened if this is 2? It's wrong. In this case, it's only when happen this n can be 0. Yeah, and n it's equal 0. Return this. Minor equal 1. Okay, let me check here. For example, if this is 0, what is happening? No, this changed to 2. Come on. What is the error? Less 1. Why less 1? In this case, the 0 go to the 1. The 1 is discarded as a part of the result, and only we have the 0. Why return less 1? Okay, I think that is because I need this, contemplate this number, the 0, 1, and 2. And in this case, for example, the 2 don't have any reference for any node and don't receive any reference. Well, in this case, I should be change this. No, this for integer I it's equal 0. It's equal 0, and while I it's minor that it's n. N I plus plus node I don't see my error. And I return less 1. No, I return 0. Because the difference between this, sure, because here the first I need transversal. I can discard this and put here. This case is only node. Finally. Very horrible performance, but well, works. Let me submit my solution. Solution using DFS Java. Okay. Now here. Okay, nice. Now okay. In degree count. What? Find champions. Starting degree in each team. Yeah. Okay. I will check this problem or this solution in the next iteration. In the next transmission. But well, I think that is enough for today. Thanks for following this transmission, and I hope see you in the next. Bye bye.